Hey there, we're going to go on to the next kind of key idea when we're solving inequalities, and that's the properties that we're going to use. So we have to come up with an understanding of what properties allow me to correctly solve. What processes can I use based on the properties of inequalities? And then how do they help me solve? Okay. So we have the addition and subtraction property of inequalities. And it says the same number can be added or subtracted from each side of the inequality sign, and the value stays the same. It looks different, but the value stays the same. That should remind you of the addition and subtraction property of equality. So I'm not going to solve this. I'm just going to use the two properties that we just discussed. So in this first one, it says I can add 2 to both sides, and it says that 3x is less than 7. These are equivalent. Okay, notice that I didn't change the direction of the inequality symbol. It stayed the same. I can also do that with subtraction. And this says 3x is less than or equal to 3. Okay, these are equivalent. They have the same values, but they look different. Now, when we start talking about multiplication and division, we have to ponder a couple things, okay? Here some nuances occur. So let's look at this first example. If I said to you 3 is less than 15, you would agree. You would rather have $15 than $3, right? Because $3 would be less than $15. Another way of saying is that 3 is to the left of 15 on the number line. So what happens if we multiply both sides by the same positive number? In this case, we're using 2. Well, if I multiply both sides by 2, then I get 6 here and 30 here. Would you rather have $6 or $30? You would rather have 30 because 6 is less than 30, correct? Right, if you look at it on a number line, here's 0, here's 6, here's 30. 6 is to the left, right? Okay. Notice that these symbols are going in the same direction. Same direction of symbol. Okay. Now, let's think about what happens if we take an expression. Let's say 4 is less than 10, and now we multiply it by a negative number. Okay. This is going to say -8, and this is going to become -20. Okay. Would you rather owe somebody $8 or owe somebody $20? Okay. You'd rather owe them $8, okay, because you wouldn't be in such debt. Here's 0, here's -8, here's -20, right? So -20 is to the left of -8. That means -8 is bigger than -20, okay? So when you multiply or divide by an opposite, I'm going to highlight that word opposite, and then I want you to interpret it as negative. Anytime you see the word opposite, you think negative. Or flip the sign, okay? If you multiply by a negative or divide by a negative, you have to flip. You have to flip the inequality symbol. Notice how we flipped. Okay? All right. Let's ponder this next situation. Again, I'm starting with 3 is less than 15. We already established that's true. What happens if I multiply both sides by 1/3? It's a positive 1/3. What's 1/3 times 3? Well, anytime you multiply reciprocals together, you get 1. 1/3 times 15 is 1 times 15 divided by 3. That's 5. Would you say that 1 is less than 5? Notice that the direction of the symbol stays the same. What happens if we take a previous example, 4 is less than 10, and then multiply it by a negative or an opposite of 1/2. Negative 1/2 or opposite of 1/2. Okay, well, that says negative 1/2 times 4 is -2. Negative 1/2 times 10 is -5. So let's put that on a number line. Here's 0, -1, -2, -3, -4, -5. Okay, left is less. So -5 is less than -2. Or another way of saying that is -2 is greater than. I multiplied by a negative number. Remember, we were going to interpret that as negative. So what do I have to do with my inequality symbol? Flip. Okay. Now what about if we divide by a number? Well, what do you think is going to happen? If we divide by 3, I'm going to get 1 and 5. 1 is still less than 5. Remember that multiplication by a third is the same as division by 3. So my inequality, my symbol, stays the same. If I divide by a negative number, in this case -2 and -2, when I simplify this, I get -2 and -5. Well, we already determined that -2 is bigger than -5. Look what has to happen. We have to flip the inequality symbol, right? So when you multiply through by a negative, opposite means negative, you have to flip the direction of the inequality sign. Okay, so that leads us into the multiplication and division properties, which we now have to have 2 of. Okay, when we're talking about a non-zero positive number that we're multiplying or dividing by, it works just like the equality property, okay, and in that I don't change the direction. So if I divide by 3, x is greater than 7/3. And then I can write that in set notation, and I can write it in interval notation. Okay. If I'm dividing by 3 and to get rid of it, I have to multiply both sides by 3 and they cancel. So I get x is greater than 7. In set notation, I use braces. And in interval notation, my smallest number is 7. It doesn't include 7 because of this symbol doesn't have the equal component. And then it's just going to keep going off to the right. But now, when I'm multiplying or dividing an inequality by a negative number, things flip, okay? So if I divide both sides here by -3, I must say that x is less than -7/3. And in set notation, it's written like that. And in interval notation, it goes off to the left forever. That's -infinity. We always use a parenthesis with -infinity. And then it goes up to -7/3, but does not include -7/3, so we use a parenthesis. I'm going to skip this one because it's kind of off the page. All right. Okay, so here's what I want you to do. I want you to watch part 3, solving. This is where we kind of get to the meat of the matter. And remember that Quizlet is due on Friday.